Dear friends, in this video we will discuss about all pair shortest path. In this we have used Floyd Warshall algorithms to get all pair shortest path. Again, the Floyd Warshall algorithms is implemented using the dynamic programming approach. Now here we have to find out the shortest path from one vertex to the remaining vertices. If you consider the source vertex 1, 1 to 2, what will be the shortest path? 1 to 3, what will be the shortest path? 1 to 4, what will be the shortest path? Similar way, consider 2 as a source. 2 to 1, what will be the shortest path? 2 to 3, what is the shortest path? 2 to 4, what is the shortest path? Then consider 3 as a source vertex. From this 3 to 1, so what is the shortest path? 3 to 2, what is the shortest path? 3 to 4, what is the shortest path? Now then consider the vertex 4 as a source vertex. Then distance from 4 to 1, what will be the shortest path? Then from 4 to 2, what will be the shortest path? From 4 to 3, what will be the shortest path? Now from the given graph, first we have to find out D0 matrix, that is distance matrix, and the predecessor matrix. Distance matrix, which gives us the direct distance from source to destination, means direct connection from source to the destination vertices. And in the predecessor matrix gives us the what will be the vertex just before the destinations on the shortest the path, right? Now here we will discuss how we have got D0 and the pi 0. Now first, distance from 1 to 1, distance from 1 to 1 is 0, distance from 1 to 2. Now see the direct connections from 1 to 2, that is the 2. Then distance from 1 to 3, there is no direct connections from vertex 1 to 3, so that's why right here infinity. Then 1 to 4, there is a direct distance from 1 to 4, that is 3. Now then start from vertex 2, then 2 to 1, there is no direct connections from 2 to 1, so that's why infinity is written here. Then 2 to 2, distance is 0. Then 2 to 3, there is a direct distance from 2 to 3, that is 1, hence 1 is written here. Then 2 to 4, direct distance is 6 is written. Now then start from third vertex, 3 to 1, direct distance is 4. 3 to 2, see whether there is direct distance from 3 to 2. 3 to 2, there is no direct distance, so that's why infinity is specified. Then 3 to 3, naturally from 3 to 3 distance is 0. Then 3 to 4, there is no direct distance from 3 to 4, so that's why infinity is written. Then 4 to 1, so there is no direct distance from 4 to 1, so that's why infinity is mentioned. Then 4 to 2, there is no direct connections, no direct distance from 4 to 2, infinity is mentioned. Then 4 to 3, there is a direct distance, a direct connection, that is 5. Then 4 to 4, naturally shortest distance is 0. Now then from the D0 we have to find out the pi 0. Now let us see the row by row how we have got the values. Now in pi 0 we have to write nil or n for diagonal elements. Now here diagonal elements are the 0. In pi 0 we have to write n or nil. Right? Now then, so in D0, wherever you are getting the infinity, so in that place write the n in pi 0. Right? Now then, in the first row here is the infinity. Now for the infinity we have written n in pi 0. Now first we have written n, okay, in diagonal places. Now then, whenever you find the infinity, so replace this infinity by the n in pi 0 matrix. Now then, let us see the first row. Now here is 0, this is the diagonal elements, that's why n is written. Now this is the 2, let us see about this. Now this is the 1 to 2, 1 to 2, distance is 2. Distance is 2, but here if you consider this 2 as the destinations, now what will be the predecessor vertex of 2? Predecessor of vertex of 2 is nothing but the 1, so that's why 1 is written. Then here is the infinity, so in place of the infinity n is the written. Now then here is 3, that is 1 to 4, 1 to 4, distance is 3. Distance is 3, but if 4 is the destination, so what will be the predecessor? Predecessor will be the 1, so that's why 1 is the written. It means that in the first row write 1, okay, for the values greater than 0 and less than infinity, and for the second row write 2 for the values greater than 0 and less than the infinity. For the third row write 3 for the values greater than 0 and less than infinity. For the fourth row write 4 for the values greater than 0 and less than infinity. Right? Now let us see the second row. Here is the infinity, n is written. Here is 0, diagonal elements, that's why n is written. Now here is 1. Let us see 2 to 3. Now what will be the predecessor vertex of 3? That is 2, that's why 2 is written. Now then 2 to 4, 6 is written. 2 to 4, shortest distance is 6. 2 to 4, that is distance is 6, but for the pi 0 matrix we have to write predecessor vertex of 4. Predecessor vertex of 4 is nothing but 2. Okay. Now then, similar way for third row, 3 to 1, distance is 4, but the predecessor vertex of 1 is 3, that's why 3 is written. Now here is the infinity, n is written. Here is 0, diagonal element, n is written. Here is the infinity, n is written. For infinity we have to write the n, nil. For diagonal elements we have to write nil or n in pi 0. Now then, so let us see last row. Now in the last row of D0, here is infinity, that's why n is written. Again infinity, n is written. Now here is a 5, 4 to 3, distance is 5. 4 to 3, distance is the 5. What will be predecessor vertex of 3? Predecessor vertex of 3 is nothing but the 4. Now in the last cell there is 0. This is nothing but the diagonal elements. So replace the diagonal elements by n. Clear? Now then, in short, in first row write 1 for the values greater than zeros and less than infinity. Then for the second write the value 2 for the values greater than zeros and less than infinity. In third row write 3 for the values greater than 0 and less than infinity. Then for fourth row, write 4 for the values greater than 0 and less than the infinity. Now in this way we have to construct D0 and pi 0 matrix. There will be total 5 distance matrices and 5 predecessor matrices. So that is, here we have started from D0, okay, and the last distance matrix will be D4. Now here, as the number of vertices are the 4, so there will be the 5 distance matrices and the 5 predecessor matrices. Start from D0 to D4, similar way pi 0 to pi 4. Now D0 is the calculated. Now go for the D1. Now for the next D and the pi matrices, we have to apply tricks. Now we have to find out D1 and the pi 1 matrices. Now here D1, so value of k is the 1. In the D0, we have to set the first row and the column. Now here first row and the first column is setted, and write this as it is in D1 matrix: 0, 2, infinity, 3. Similar way, right row, infinity, 4 and infinity. In pi 1 also, write first row and the first column as it is, first row and the first column as it is. That is n1, n1. Then write column n3 and n. Now then, we know that, so diagonal elements will not change in D1 as well as the pi 1. So write the diagonal elements as it is: 0, then 0, now then 0. Similar way in pi 1, write n, n and n. Now we have to fill up the remaining values. So already first row is written. Now then check the second row. In the second row, first value and the second value is written. Now we want value at this place. For this, we have to track the same place in D1. Now first value we have got, that is 1. 1. Now then, from this, travel up so that we will reach to horizontal line. Now here value is infinity, plus from the same place travel to left side so that we will touch to vertical line. Here is the infinity. That is equal to infinity. Now find out which one is the minimum. 1 is the minimum. So write here the 1. It means that same value we have written, there is no change. If there is no change in the D1, so there will not be the change in the pi 1. Now same value we have to consider from pi 0 for pi 1, that is 2. Let us see for this place. Track same place in D0, that is 6. First value is 6. Now then, from 6 travel up so that we will touch to horizontal line and we get the value 3, this value. Similar way, from this place travel to left side so that we will touch to vertical line, and at this point value is infinity. So 3 plus infinity is nothing but infinity. We have two values, 6 and infinity, and out of these two values 6 is the minimum. Then write 6 here. If you see, this value is not changed. Okay, same value we have written from the D0. It means that, so there will not be the change in the pi 1. Means the same value we have to specify here. Now see the third row. Now let us see which value will come here. Now track the same place in the previous matrix. Here the previous matrix is D0 and the place is the infinity. Now we have got the infinity as the first value. Find out the second value. Now from infinity travel up to reach horizontal line, that is 2, value is 2. Then from this place, from infinity travel to left side so that we will touch to vertical line. Now here we are touching to the vertical line, and now here the value is 4, right? 4, that is equal to 6. Now here we have got two values, infinity and the 6, and the minimum is here the 6. Now value is changed. In D0 value is infinity and in D1 value is 6. It is changed. Now if in the D1 value is changed, there will be change in pi 1. Here will be the change. Let us see what value will come here. See here. Now we have traced the same place in D0. Okay. Now then we travel upside to touch to horizontal line. Right. Now here is the 2. Now see the place in the pi 0. Okay. Same place in the pi 0 and find out which value is there. Now this is a pi 0 matrix and place is 1 to 2. Okay. Now go to the same place 1 to 2 and see which value is there. Now here is the 1. It means that at this place there will be 1. I am repeating here. Now once the value is changed in the D1, so there will be change in pi 1. Let us see which value will come in the pi 1. In the D1 value is changed. Okay. Now once the value is changed in the D1, in pi 1 also value will the change. Same value will not come. So there will be the change. Okay. Let us see which value will come here. Now track this place in D0, that is infinity, then travel upside so that it will touch to horizontal line. Now here we have the 2 and find out this place. This place is 1, 2. Okay. Now go to the same place in pi 0. Okay, place which place is there? 1, 2. Now in pi 0, 1, 2, on 1, 2 place there is 1. There is 1. So that's why 1 will come here. 1 will come here. Now then, for this place, let us see which value will come here. Now, find out the same place in D0, that is infinity. Means we have got the infinity. Then find out the next value. Now from this travel upside so that we will touch to horizontal line, 3, plus from the same place travel left side so that we will touch to vertical line, value is 4. We get 7. In this way we have got two values, infinity and the 7. Infinity and the 7. Minimum is the 7. So write here the 7. Means the value is changed. In D0 value is infinity, in D1 value is the 7. In the D1 is changed, it means that there will be change in pi 1. There will be change in the pi 1. Now let us see which value will come here. Apply the same process. Now go to D0, okay, on this place. So place in the D0 is this one, infinity. Travel upside so that we will reach to horizontal line here. Okay. So track the same same place in the pi 1. In the same place means this one. Okay. So 1 to 4. Now here value is 1. Means as the value is 1, now here you will get 1. You will get 1. So in this way, third row is constructed. Now then go to the last row. Now let us see which value will come here. Now trace the same place in D0, that is infinity. So we have got the infinity as a first value. Then the second value will be 2 plus infinity. That is infinity. Means both the values are infinity. Means which one is the minimum? Naturally infinity. Infinity. It means that this is not change. Okay. So there is a no change at this place in D1. No change in the pi 1 at this place. So here will be n. Same value we have to put here. Now then which value will come here? Now go to the same place in D0. Now this place, here value is 5. Now then find out the next value. Go up. Here you will get infinity. Then go left. Here you will get infinity. That is infinity. So which one is the minimum? So 5 is the minimum. Okay. Means there is a no change at this place. So that's why there will not be change in pi 1. 4 will come. In this way, D1 and pi 1 matrices are constructed. Then find out the D2 matrix. D2 matrix taking the reference of the D1 matrix. Taking the reference of previous matrix. Now here k is equal to 2 in the D1, in the just previous matrix, said second row and the second column. Said second row and the second column. Second column. So write this as it is in D2. Write this as it is in D2 and pi 2 matrices. Pi 2 matrices. So right here. So this is the infinity, then 0. I am writing second row 1, 6. Then write second column 2, 0, 6 and infinity. Now write down the diagonal as it is, because there will not be change in diagonal elements. 0, then 0, then 0. Now similar way, develop pi 2. Pi 2. So write second row and second column as it is. N, 2, 2. Now then second column 1n, 1n. Then so write diagonal values as it is. N and n. Now then, so missing values we have to find out. Now try to find out row wise. Now we have to find out this value. For this we have to refer the previous matrix. Now here we have to trace this place in D1. Okay, this one. Now here value is infinity. Here value is the infinity. Now then, so travel down so that we will reach to horizontal line. We have the 1. Now then from same place travel to left side so that we will touch to vertical line. Here the value is 2. that is 1 plus 2 is 3. We have two values, infinity and 3. So which one is the minimum? 3 is the minimum. So write 3. Write 3. Now here value will change. In D1 it is infinity. Now in D2 it is 3. It is changed. Once it is changed in D2, okay, it has to be changed in pi 2 here. Now let us see, so which value will come in place of this cross. Now then, in the D1, go to the same place, that is this one. Then travel vertically so that we will reach to horizontal line here. Now, here trace the same positions in pi 1. Same positions in the pi 1, that is 2. Now 2 will be the value of this cross. 2 will be the value of this cross. Remember this one. This place. This place means these three values in D1, that is 3. Then travel vertically so that we will touch to horizontal line. Here value is 6. Now then travel to left side so that we will touch to vertical line. Value is 2. 6 plus 2, that is the 8. So which one is minimum? 3. So write 3. Now here, so there is no change. So that's why there will not be change in pi 2. So 1 will be as it is. 1 will be as it is. Already we have written the second row. Now then go to third row. This place. Now then track this place in D1 matrix, that is 4. 4. Then travel vertically so that we will touch to horizontal line, infinity, plus travel to right side so that we will touch to vertical line, that is 6. So infinity plus 6, nothing but infinity. Infinity plus 6 is equal to infinity. So which one is the minimum? 4. It means that there is no change. It means that there will not be change in pi 2, that is 3. Same value will come here. Then find out the value for these positions. Okay. So track this position in D1, that is 7. So write the first value, that is 7. Then find out the second value, just traveling vertically and horizontally. Now if you travel vertically so that we will touch to horizontal line, value is 6, plus now from these positions travel left side so that we will touch to vertical line. Here value is 6. 6 plus 6, that is 12. Minimum is the 7. So write here the 7. No change. Now here write 1 as there is a no change in D2 matrix. D2 matrix. Right? Now then. So find out D3 and the pi 3. Okay. So fourth row is left. So find out the value for these positions. Then trace these positions. Track these positions in D1. That is infinity. Infinity. Then travel up so that we will touch here. Infinity. Then from this place travel to right side so that we will touch to vertical line. Now here we get the infinity, that is equal to infinity. So we have both the values infinity. So here the infinity will come, means there is no change. Okay, as there is a no change, so there will not be no change in pi 2. So here n will come. Now then find the value for this position. So here track the values in D1, you will get 5. Then so travel vertically, you will get 1 plus travel horizontally, you will get infinity. So that is equal to infinity. Minimum is 5, means there is no change. Okay, here also no change. In pi 2 there is no change. In this way, so we have completed D2 and pi 2 matrix. Now then go for D3 and pi 3 matrix. So here I write D3 and pi 3. Now here k is equal to 3. We have to set third row and the third column of previous matrix. So this is the previous matrix. So third row and this is third row and this is third column. Similar way for pi 2, this is third row and this is third column. So write this as it is in D2 and the pi 2. So write here the 4, then 6, 0, 7. Here 3, 1, 3, 1, 0, 5. Now in pi 3, write 3, 1 and 1. Now then 2, 2, n and 4. Okay. Now then, so diagonal elements will not change. So write 0, 0, 0 and 0. Similar way in pi 3, diagonal elements will not change. Write n, here n, here n. Okay. Now try to get the missing values. This value. Okay. Now find out this place in D2. That is 2. That is 2. Means first value is 2. Now then travel vertically, you will get 6. From same place travel horizontally, you will get 3. 6 plus 3 is nothing but the 9. Minimum is the 2. Means there is no change. Now if there is no change in D3, there will not be change in the pi 3. So 1 will be in pi 3. Then find out the value for this place. Means find out this place in D2, that is 3. Value is 3. Now then travel vertically, you will get 7 plus, then travel horizontally, you will get 3. 7 plus 3 is nothing but 10. 3 is a minimum. 3 is minimum. So write here 3. Write here 3. It means that there is no change. So then the 1 will be the as it is. This one. Right? Now then find out the second row's values. Okay. Now then go to these positions in D2, that is infinity. First value is infinity. Find out the second value just by traveling. So travel vertically so that we will reach to horizontal line. We get the 4. Then from the same positions, so travel horizontally, travel right side so that we will touch to vertical line, and here value is 1. That is 5. So which value is minimum? 5 is the minimum. So write here the 5. here the value is changed. In the D2 it is infinity, in D3 it is the 5. As the value is changed, so there will be change in the pi 3. So here we will get the new value. Here we will get the new value. Now let us see. From this place we have to travel vertically so that we will touch horizontally. Yeah. Now then, so go to the same place in pi 2. Same place in the pi 2. Now here value is 3. Now 3 will come at this place. 3 will come at this place. That is 3. That is 3. Right? Now then, find out the value for this one. Infinity. So value for this cross. Right? Now here, go to this place in D2. Here value is 6. Here value is 6. 6. Now then travel vertically and horizontally. If you travel vertically you will get 7. If you travel horizontally you will get the 1, that is 8. So minimum is 6. Minimum is 6. It means that there is a no change. Now if there is a no change in D3, so there will not be change in the pi 3. The pi 3 there will be 2. So 2 will come here. Right? 2 will come here. Now then, third row is already filled up. Now go to the last row, that is the fourth row. Now find out the value for this position, for this place. So first, now go to D2, okay, at this place. So you will get the infinity. Then travel vertically, you will get the 4. Then travel horizontally, you will get the 5. 4 plus 5, that is 9, and minimum is the 9. Here it is changed. So write here the 9. Okay. So as there is a change in D3 at this place, so there should be the change at this place in pi 3. Right. Now then, so from this place go to the vertically so that we will touch to horizontal line. That is 4. Okay. Now then, so see the value at this place, okay, in pi 2, that is 3. So 3 will come here. So 3 will come here. Now then, this place. So here we have infinity, first value. Then 6 plus 5, that is 11. So write here the 11. Now here value is change. Okay. Then there will be change in pi 3. There will be change in the pi 3. Now from this place travel upside so that we will reach to horizontal line. Now here value is 6. Okay. Value is 6. And go to the same place in the pi 2. So you will get the value, that is 1. Okay. So 1 will come here. 1 will come here. So these are the tricks to find out the values. Okay. Now then, find out D4 and pi 4. So this is the last matrix. Now here value is 4, means k is equal to 4. Go to the matrix, then set the fourth row and the fourth column. Fourth row and fourth the column in D3 as well as the pi 3. Right? So write this as it is in D4 and pi 4. That is 9, 11, 5, then 0, then 3, 6, 7 and 0. Similar way in pi 4, write the fourth row and the fourth column 4, and the fourth column is 1, 2 and 1. then the diagonal elements will not change. Write the diagonal elements as it is. 0, then 0, then 0. Now similar way in pi 4, write nil, okay, in the diagonal as it is. So there will not be change. N, then N, N. Right. Now rest of the places we have to fill up. Now then this place, let us see which value will come here. So go to the same place in D3, you will get the 2. Okay. Then travel vertically and the horizontally. If you travel vertically, you will get the 11. If you travel horizontally, you will get 3. So that is 14. So which one is the minimum? 2 is the minimum. Then there will not be change. Okay. So here also there will not be change. Then this place. Now go to the same place in D3. You will get the value 3. First value. Then find out the next value. So that is 5 plus 3. That is 8. Minimum is 3, means there will not any change. 3. So here will be 2 as it is, no change. Now then go to the second row, this place. Then find out the same place in D3. You will get the value 5. Then travel vertically, you will get the 9. Then from the same place travel horizontally, you will get 6. So 9 plus 6 is nothing but 11. 9 plus 6 is nothing but 15. So which one is the minimum? 5. So write here 5. Okay. So there is no change. Then there will be no change in pi 4 also. Then this place. So go to the same place in D3. It's 1. First value we have got, that is 1. Then from this travel vertically and horizontally. If we travel vertically, so you will get the 5. If you travel horizontally, you will get 6. 5 plus 6 is nothing but the 11. Minimum is 1. So there is no change. 1. Now here is 2. No change in the second row. Then try to fill up third row. This place. Now go to the same place in D3. So you will get the value 4. Then travel vertically, you will get 9. Travel horizontally, you will get 7. So that is 16. So which one is the minimum? 4 is the minimum, means no change. Now here also in the pi 4 there is a no change. 3 will come here. Now then at this position. So find out the value for this position. So just go to the same place in D3. You will get the 6. First value is 6. Then second value will be 11 plus 7. So that is equal to 18. Minimum is 6. Here will be 6, means the no change. Now, so there is a no change, means there will not change in the pi 4. So 1 will be as it is. 1 will be as it is. So in this way, we have filled up the D4. D4 is the last matrix. So in this way, so we have got 10 matrices starting from D0 to D4 and pi 0 to pi 4. So this last matrix is nothing but the shortest path distance matrix. Okay, and this is nothing but the predecessor matrix. Now the values which are specified in the D4, these are nothing but the shortest distance. Okay. Now let us see from 1 to 2, distance from 1 to 2, distance from 1 to 2 is nothing but 2, right? Now then distance from 1 to 3, distance from 1 to 3 is nothing but 3, right? Then distance from 1 to 4, distance from 1 to 4 is 3. Distance from 1 to 4 is 3. Distance from 1 to 2, distance from 1 to 2 is nothing but 2. Distance from 1 to 2 is nothing but 2. Distance from 1 to 3, see here, 1 to 3. Distance from 1 to 3 is nothing but 3 here. Shorter distance is 3. Distance from 1 to 3 is 3. Okay. Now, so we have to find out the path for this. So, path will be 1 to 2, then 2 to 3. Right? So, let us see this example. That is, distance from 1 to 3 is nothing but 3. Distance from 1 to 3 is nothing but 3. You write here 1, 2, 3, 4. These are nothing but vertices. 1, 2, 3, 4. Right? So distance from 1 to 3 is nothing but the 3. But there is no direct distance from 1 to 3. Right? Now we have to find out the path for this. Distance from 1 to 3. Distance from 1 to 3. So there is no direct distance from 1 to 3. But now to find out the path, predecessor matrix can be helpful. Predecessor matrix can be the helpful. Now if you see 1 to 3, distance is 3. Okay. Now then in the pi 4, if you find out 1 to 3, you will get the 2. So 2 is nothing but this value. 2 is nothing but the predecessor vertex of 3. So I write here the 2. This 2. Okay. So it means that 2 to 3, we have the value 2 to 3 is nothing but the 1. Now then 1 to 2, so here 1 to 2 is nothing but 2. 1 to 2 is nothing but the 2, and in the pi 4, 1 to 2 means the 1. This 1 is nothing but the predecessor of the 2. Predecessor of the 2 is nothing but the 1, means there is a direct connections. And the distance between 1 to 2 is nothing but the 2. Okay. So in this way, we can find out the shortest distance with the path. Okay, taking the help of the distance matrix and the predecessor matrix. Predecessor matrix is useful to get the previous vertex of the destination. Previous vertex of the destinations. So in this way, so we can solve the all pair shortest path problem. Okay. So using Floyd Warshall algorithms. Next video we will discuss about traveling salesman problem. Thank you.